In the last two episodes, we covered the HLD of the agent, the React loop. Reason, act, observe, repeat. That was the concept in the architecture. This episode is the code that runs it. There's one thing before we move forward. The loop is not a loop you write. There's no for or while line you type by hand. It's a LangGraph object you build. It's a state machine. You declare its shape once, and a streaming function walks it one step at a time. This is episode 3 of Building YUYUTSAVA. We'll look at the few pieces of code that build and run this loop, and why they're written the way they are. The whole project sits inside one Python package, YUYUTSAVA. That's the top of the tree. Inside it, several folders. Today we need one. The core folder. This is where the brain of the agent lives. 3 files, all in core. LLM.py. It contains the model calls. Engine.py, where we build the loop. And streaming.py, where we run it. That's the whole map we need. Let's build the loop. One mental model first. In YUYUTSAVA, the agent has 2 sides, and they live in 2 different files. The first side is the build side. This is where we take an LLM, take a set of tools, take a backend, and assemble them into the loop. The build side does not run anything. It produces an object, a compiled state machine, the loop, frozen into a shape, ready to go. The second side is the run side. It takes that compiled state machine and drives it. It feeds in your task, walks the graph step by step, and streams every decision back to you. Build the loop, then run the loop. 2 files, 2 responsibilities. The build side is engine.py. The run side is streaming.py. Everything today lives in one or the other. First we build, then we run. In episode 2, we said the engine never talks to a provider directly. It talks to a contract called LLM settings. That contract lives in config.py, and it's tiny. A protocol that says anything with an API key, a base URL, and a model counts as LLM settings. Nothing more. And in that same file, each provider is a small settings class that fills in those 3 fields: Grok, OpenRouter, Anthropic, Ollama, and many more. One function reads a single environment variable, LLM_provider, and hands back whichever one you picked. So config.py answers one question, which model? Then there is LLM.py file, which answers the other question, how to build it. Its function chat model takes those settings and returns a live client, settings in, a model out. If the provider is Anthropic, it returns one kind of client. Otherwise, Grok, OpenRouter, Ollama, or any other provider, they all collapse into one OpenAI-compatible client. Same temperature, same token limit, same shape coming out. And that's the point of splitting it this way. Everything above receives one object, a chat model, and never learns which provider produced it. This is principle 2, design by contracts. Add a provider, or switch one, and only these 2 small files are touched. Nothing else breaks. Now the build side, in engine.py. This is the function that assembles the agent. Create DeepAgent. It comes from DeepAgents, which is a framework from the LangChain built on LangGraph runtime. DeepAgents is the opinionated layer on top that wires the React loop, the tools, and the middleware into it. That's the design choice. We don't hand-build the graph. We declare our parts, and let the framework compile the loop. This is the call that builds the agent. What we pass it isn't loop code, it's parts. The model, the chat model from LLM.py. The tools, what the agent is allowed to do. The backend, where those tools run, local shell or Docker sandbox. The system prompt, who the agent is, on every turn. The checkpointer for its memory. And the middleware, which is the safety harness. All these are passed in this function, create DeepAgent. There are a couple more arguments, sub-agents, and some advanced options. But we leave those defaulted here. They're for later episodes. What matters is the shape of this. Every argument is a part we choose, and the framework wires them into a running loop. This is the shape it produces, the actual state machine. Start at the top, then the model node. The LLM looks at the conversation so far and decides, call a tool, or am I done? This is reason. If it wants a tool, the graph routes to the tools node. The tool runs, this is act. The result flows straight back into model. That return arrow is observe. Model to tools, tools back to model. That is the loop, and it's an edge in a graph, not a line you wrote. When the model decides it's done, no tool call, the graph routes to the end. Final answer, loop over. And those extra boxes, the middleware, are nodes in the graph too. The safety harness from episode 2 isn't bolted on the side. It's wired into the machine itself. There's one argument on that build call we skipped past, the checkpointer. It answers an obvious question. If the loop is just a graph, how does the model on step 10 remember what happened on step 1? The answer is the graph's state, and the state is simply a list of messages that grows. You start with one message, the human task. The model adds a message, a tool call. The tool adds a message, its result. The model adds another. The list grows with every step. The checkpointer is what saves that list after every single step. It's one line with a sane default. If you don't pass one in, YUYUTSAVA uses memory saver and in-process store. And it's keyed by a thread ID. One thread ID, one conversation, one growing state. That is what gives the loop memory. And because the state is saved after every step, the loop can be paused, inspected, and resumed, which is exactly what the next two pieces rely on. So that's the build side. We took a model, a set of tools, a backend, and a safety harness, and DeepAgent compiled them into one object, a state machine with the loop already wired inside. But nothing has run yet. It's just sitting in memory, waiting. So how do you drive it? That's the run side, streaming.py, whose only job is to walk that loop and surface every step. What we feed in is one thing, the human task, as the first message. That's the only input the loop ever gets from us. There's a while true wrapped around this, but it is not the agent loop. The agent loop lives inside the graph. This outer while exists for one reason only, to let the agent pause, ask a question, and continue. On a normal run, it passes through once. The real work is this one call. We call a stream on the graph, and we ask for two streams at once, stream mode, messages, and updates. We chose those two deliberately, because together they are exactly reason, act, and observe, arriving as events we can watch. The messages stream is the LLM's tokens, arriving as it generates them. This is reason. You're literally watching the model think, word by word. The update stream is the state changing. When an update carries an AI message with tool calls, that's act. The agent decided to do something. And when an update carries a tool message, that's observe. The result came back. Reason streams in. Act fires. Observe comes back. And because it's a graph, the model node simply runs again on the new state, and the next round of tokens streams in. This is the entire loop, no longer a drawing. It's a sequence of typed events you can read, log, and render in real time. That's Principle 5 observability, and it was free because the loop is a graph that streams. Two last pieces, and both are design decisions from episode 2, now as code. Principle 4. The loop needs a governor. When we run the graph, the config we pass carries one setting recursion limit, 200 by default. If the agent hasn't finished in 200 steps, the graph stops. No infinite loop. No runaway bill. One line of configuration caps the entire machine. This is where that while true from the last scene comes in. Remember the safety harness, the permission layer. When the agent tries something dangerous, the graph doesn't power through. It fires an interrupt. When the stream carries that interrupt, we catch it and collect what the agent wanted to do. The loop pauses, exactly where it is. And because the checkpointer already saved the state, the pause is safe. Nothing is lost. The graph is frozen, mid-loop. So we ask you, on the command line, the agent wants to run this command, yes or no? You answer. We send your answer back in with a single instruction, command resume, and the graph picks up exactly where it froze. That's human in the loop, and in code, it's one pause and one resume. We built that outer loop solely to make the exchange possible. A governor that caps the loop, a pause button that suspends it. Both possible only because the loop is a state machine with saved state, not a 4-line you'd have to babysit yourself. So that's the agent loop. In code, build the graph, compile it, stream it. The loop is a state machine you declare, not a for loop you write. Its memory is a checkpointer. Its life is a stream of reason, act, and observe. And its safety is a governor and a pause button, wired into the machine itself. In the next episode, we go one layer deeper, into the tools. What the agent can actually do, how each tool is defined, and how we swap the entire backend underneath it without the loop ever noticing. Subscribe so you don't miss it. See you in episode 4.